Let's take a look at all the things we learned in this unit. There are 3 different ways to graph a line. The first way is slope-intercept. When you see y equals, the slope is going to be the number in front of the x, and this other number is your y-intercept. It always has a 0 for x. This is the y-intercept. The point is on the y line right down here. And then I will use the slope. Up 2 over 3. Up 2, 1, 2, 3. Up 2, 1, 2, off the graph paper. When you draw your line, make sure you make a nice long line with arrows because it's just a math problem. The second type is standard form. Standard form means you have your x's and your y's on the left side, equal sign, and then your numbers. So ax plus by equals c. To find the x-intercept, you let y be 0. 3 times 0 is nothing. Negative 6x equals 12. Divide both sides by negative 6, and x is negative 2. And the y number was 0. For the y-intercept, I will let the x value be 0. 6 times 0 is 0. And so I have positive 3y equals 12. And the y number is 4. So the y-intercept point on the y line is going to be 4. The x-intercept is negative 2. And when you graph this line again, okay, it's a long, long line with arrows. Okay, what is the slope of this line? Up 2 over 1. Up 2 over 1. Okay, up 2 over 1. These are all the points on the line. And the last way you can graph a line is if it is in point-slope form. So where is the slope always located? In front of the x. Negative 2 over 1. Okay. And what is the point for this equation? The x value is negative 3 because x is by x, but remember he's always opposite. And the y value is a 4. He's always alone. So the starting point is negative 3, 4. Here it is. Okay. Will the line be increasing or decreasing? The line needs to be decreasing since it's a negative slope, down 2, and positive goes to the right. Down 2 over 1, down 2 over 1, down 2 over 1. You fill up the graph paper with as many points as you can, and you draw your nice long line with arrows. Those are the 3 ways that we have learned to graph a line. Now this chapter is all about finding solutions to systems. Okay, let's determine if this point is a solution. Let's check this point. Okay, it has to work in both of the equations. So the x value is negative 1. The y value is 4. I will replace the x number using parentheses with negative 1. And then the y number is a 4. So 4 will go into the y spot. Okay. Now we have to check this. So we will type this into our calculator to see what it makes. And this side is negative 17. The question is, what does this make in your calculator? And if I type it in, negative 3, parentheses, negative 1, minus 5 times 4, and the calculator says negative 17. So was this point a solution to the first equation? And it was. But remember, it must work in both. So now I will check it in this equation over here. So the x number is negative 1, use parentheses, minus your y value, which is a 4. Okay, and the equation says 1. So you drop that down. The question is, what does that make? And if you use your calculator, the answer is negative 7. Okay, Does -7 equal 1? The answer is no. It worked for the first one, but it did not work for the second one. So is it a solution for the system? You're going to want to say no, okay? It did not work for both. Okay. What else did we study this chapter? Okay. There's 3 different ways to solve a system, and the first way is with graphing. So now we're going to use those graphing skills from the first page. Okay. This first equation here, line 1, is in standard form. So we will be finding the x-intercept and the y-intercept. To find x, I cover up y. -5x equals -30. And what is the x number? 6. Now let's cover up x. Let's find the y number. That's a +5y equals -30. And the y value is -6. So these are 2 points. We will not be putting them together. These are 2 separate points. 2 points that stay separate. The x-intercept touches right here on the x-axis, and the y-intercept touches down there at -6. So when we line this up, make sure to use your ruler, nice and straight. Okay. And we have many, many points along this line. One of them might be the solution. Okay, I'm going to switch colors for the second line. This second line right here, okay, this one is in slope-intercept form. Okay, what are the key features for slope-intercept form? We have an M and we have a B. A B is a y-intercept. The slope number right here is -1. And what is the y-intercept number? -2. So we will start on the y-axis at -2. The slope is down 1 over 1. Let's make sure I have a decreasing line. Down 1 over 1. Down 1 over 1. Winner, winner! I found the point. Down 1 over 1. Down 1 over 1. You're going to want to make sure you go the other way too, just so your line is not crooked at all. And when you draw your nice long line with arrows, okay, the solution is the point that they have in common. So the solution is the point right there. The x value is 2, and the y value is -4. Let's graph a system again. Okay. I'm going to color code the first equation right here. What form is this one in? This is standard form. ax plus by equals c. When you are in standard form, what are the key features? We have x-intercept and y-intercept. The x-intercept cover up the y, and what is -8x equals -16? The x number is going to be a 2. The y-intercept, let x be 0. And when you solve this, what is the y-intercept number? A +4. So we touch the x-axis at 2 and the y-axis at 4. So let's graph this line before we get confused. These 2 points make this line right here. Okay. And let's go ahead and graph our second equation. Okay. This one is in point-slope form. So what is the slope of this line? The slope is right there in front of the x, -2 over 1. Okay, and what is the starting point of this line? The x number is a +2 and a -6. So let's start at 2, -6 down here. And I will go down 2 over 1, down 2 over 1, up 2, left 1, up 2, left 1, up 2, left 1. It does not seem like these lines are touching. Okay. If the lines are perfectly parallel, they will never touch. The slope of this line is definitely down 2 over 1. Let's check the slope of this line to make sure. Down 2 over 1, down 2 over 1. They are parallel. So when the two lines are parallel, there will be no point in common, no solution. Okay? And that's what this little diagram down here shows. Okay? If the lines intersect, we will have one solution right there, and you find the point. If line 1 is right on top of line 2, then there are infinitely many solutions because they touch over and over many points. But if your lines are perfectly parallel, down and over, down and over, if they do not touch, then there is no solution. Check the slopes to be sure. Let's take a look at how to solve algebraically. There's two ways that we learned. The first way is substitution. We find an isolated variable. Isolated means alone. So we're looking for x equals or y equals. Which letter do you see isolated in this system? The letter is y. So I will circle this stuff. In the other equation, we are going to put parentheses where the y is. So let's write down our equation, but instead of a y, I am going to be putting this stuff into the parentheses. When you do this, you should only have one letter. We should only have x, x, x. Perfect, I can solve. What's the first step in solving an equation like this? The first thing we're going to do is distribute the negative 3. So let's drop down 6x. Negative times negative is 9x minus 18 equals negative 18. We still have x's, so I have to keep going. Okay. What will the next step be in solving this? The next step is going to be to add like terms. Let's go ahead and add these x's to make 15x. Copy the rest of the problem. Okay. And now we're just going to continue to solve like normal. Let's solve. Plus 18 plus 18. 15x equals 0. Now I still have a letter. If you still have an x, that means we are going to get a solution. When I divide by 15, is that possible? Okay, and the answer is yes. 0 divide by 15 makes a 0. Okay, and so that is a very nice answer for x. Our solution is 0, comma, I have to go find the y. Okay, the easiest place to put your value is the isolated variable. I will put 0 in for that x place. So make sure you write y equals negative 3 times 0 plus 6. And what is the y value? The y value is 6. Okay, substitution is good when you have a letter alone. Let's take a look at standard form. Standard form, okay, is when a variable is going to cancel. We have our x's lined up, our y's lined up, and our numbers. Okay, do these x's cancel? No. Do these y's cancel? Okay, the answer is yes. Let's go. Okay, so then you're going to add the columns together. How many x's is this? 9x. The y's cancel. Let's go ahead and add those together. What do you get with negative 38 plus 56? Yeah, we get 18 on that side. Divide both sides by 9, and our x value is 2. So we are halfway done. We have 2 for our x value. Would you like to replace the 2 into this bottom equation or this top equation? It doesn't matter. Let's pick the one that looks a little easier. I'm going to pick the bottom one. there's less negatives. So 22 times 2 minus 6y is 56. Let's multiply these together. And now let's solve. Minus 44 from both sides. 56 minus 44 is 12. And what is the y value? Negative 2. Okay. We can check to see if this works. We can put the 2 into the x spot, the negative 2 into the y spot, type it in our calculator, and let's see if it makes negative 38. Negative 13 times our x value. There we go. Plus 6 times our y value, which was negative 2. And does the calculator say negative 38? It does. But remember, it must work in both. Does it work in this one? Yes, it does. Let's take a look at elimination, okay, where we have to do some work. These x's are not canceling, and these y's are not canceling. So I have to think about this. A 4 and a 6. 4 times 2 is 8. That does not cancel. 4 times 3 is 12. And that doesn't cancel. But can you turn a 6 into a 12? So if I multiply this by 3, that's a minus 12. And if I multiply this one by 2, that's a positive 12. I think I've made the plan. So for the top equation, negative 12x minus 18y. Don't forget to do this one. What is 3 times negative 18 make? Negative 54. For the bottom equation, let's multiply everybody by 2. 12x plus 18y equals negative 8. All right, the x's cancel, the y's cancel. What number are we getting here? There's no letters. We have a 0. Over here, I add these together, and we get negative 62, and that is not equal. Okay? Does 0 equal 62? No, and so my answer is no solution. No solution. Okay, when you're doing algebra, there's 3 ways that this can happen. If you still have an x, that means you have one solution. You're halfway to getting the point. If all your x's cancel and this is not equal, okay, then you say no solution. If your x's all cancel, you have no more letters, but this is true, then you get infinitely many solutions. If all your letters disappear, special answer. If you still have x, keep going. What else did we study? The last thing here is word problems. We either have standard form or we have slope-intercept form. So let's take a look at this. The hamburger meal costs $5 plus $2 per side. And the cheeseburger costs $6 plus $1 per side. Per or each or every, that gets the variable. Now the question is going to help us define the variables. How many sides? How many? How many means number of. Number of sides. For the total cost to be the same, so y is going to be the total cost. So now I'm going to write my equations. Okay. We've got hamburger meal costs $5. So I'm going to write just a 5 plus $2 each side. $2, but now I need to put the x for the sides. And where does the y go? It must be y equals. Your second equation will also be y equals. It starts with 6 plus $1 per side, 1x. And so there is your system of equations. X was number of sides, so on my graph I will put number of sides, and the y stands for total cost. And I will graph these two lines now. The first one starts at 5, that's the y-intercept at 5, and I will go up 2 over 1, up 2 over 1. I can't buy negative sides, so I'm only going to put the arrow on one side. And so this is the hamburger meal. I'll put H for hamburger. And what about the cheeseburger meal? This equation starts at 6 of a y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. And so winner, winner, I just found the point they have in common. This is the solution. The point is 1, 7. So the solution point is 1, 7. But what does that mean? I can look at the question. How many sides can be ordered for the total cost to be the same? Okay? And the answer is 1. Okay? The total cost is the same. The total cost is the same if one side is ordered. And what is the total cost? The total cost is, I should say both $7. They're both $7 when you order one side. How about the other equation here? We've got a couple things. 8 bagels and 4 muffins cost a total of this. A total of 6 items were ordered. How much did 1 bagel and 1 muffin cost? So do you know the two things we're talking about here? We've got bagels and muffins. How much did it cost? So the first one's going to be cost of and cost of. The first one is a bagel, and the second one is a muffin. So those are my two variables. Now to make the equation, we have 8 bagels. 8 bagels. Bagels is x. And 4 muffins. 4. The muffins is the y. And the total for 8 and 4 was $32. But the other total is 6. Is 6 items bagels or muffins? And the answer is both of those things. It's the bagels plus the muffins. Let's go ahead and label our axes. X is going to be cost of the bagel. And your y is cost of muffin. The cost of the muffin. And I want to see where they intersect so I can answer this question. The first equation is in standard form. So the x-intercept, 8x equals 32, is 4, 0. And then the y-intercept, okay, what's the y number going to be? 8. So we have the line from this y-intercept point down to this y-intercept point. And let's take a look at this second equation right here. Okay, when you cover up y, x equals 6, so that's very easily 6, 0. And when you cover x, what's the y-intercept? 0, 6. So let's use our ruler to make sure we can see where these two lines crisscross. Okay. And the intersection point is right there at the point 2, 4. And so what does that point mean? Okay. 2 is cost of a bagel, and the 4 is the cost of a muffin. The question says, how much does one bagel and one muffin cost? I know the answer now. The bagel costs $2, and the muffin costs $4. Great job with Chapter 6.